Um, just looking at a couple of things. First off, we're going to approximate the square root of 10. Now, if I asked you to give me an approximation of the square root of 10, what would you tell me at first?
2 points.
Numbers.
But a little greater than 3, right? And why do we know this?
Because square root
Yeah.
is 9.
Square root of 9 is 3. So, what I'm going to do here is I'm going to use this fact that I know that if f of x is equal to the square root of x, then f of 9 is equal to the square root of 9, which is equal to 3, to use my approximation. So, I've got this graph. I've got the point 0, 0. I've got the point 1, 1. I've got the point 4, 2. And then over here, I have the point 9, 3. And I'm interested in this 10 value here. So I've got that graph there. Now, based on that graph there, if I can construct the tangent line to the graph here, I can use that tangent line to approximate the value of the square root of 10. So, what do I need to know in order to construct a line? Slope. And what?
A point.
And a point. Slope and a point. Well, my graph is f of x equals the square root of x. And I know that I have the point 9, 3 on that graph. Right? Okay. Now, what is the slope there? Well, we're in calculus class, so what comes to mind when you think of slope?
Slope formula.
What'd you say? Starts with a D. Sounds like a derivative. Derivative, yes.
Sounds like
So, if I have f of x equals the square root of x, then f prime of x, and we've done this several times, is 1 over 2 square roots of x. So, if I want to know the slope at 9, I have f prime of 9 equals 1 over 2 times the square root of 9, which would be 1/6. So I have my point and I have my slope. So I'm going to go to point slope form, which says that y minus y sub 1 equals m times x minus x sub 1. So y minus 3 equals 1/6 of x minus 9. Are y'all with me? Okay. So based on that, I get that y is equal to 1/6 x minus 9/6, which I'll call 3/2, and then plus 3. And 3 is 6/2. So I get y equals 1/6 x plus 3/2. So what is that x value that I'm wanting to know the approximation for? It's 10, right? Are y'all with me? Okay. So y equals 1/6 of 10 plus 3/2. So 10/6 is 3/2. So 3/2 plus 3/2 is, I've done something wrong. This is 5/2. No, 5/3. Wow, that was horrible math. I'm glad y'all didn't see me do that. So this is 2 over 2, this is 3 over 3. So it's 10 plus 9 over 6, which would be 19 over 6. Now, what is just put it on my desk here. What is 19 over 6 approximately as a decimal?
3.1666.
3.67.
16, repeating 7.
And what is the square root of 10 if you put that in your calculator?
About 3.167.
1627.
3.1627?
Yeah.
Okay, so they're pretty close. Not a perfect approximation, but a very close one. So this works for square roots. It works for square roots that are bigger than a value. It also works for square roots that are less than a value. So let's say that I want to approximate, well, let's do a cube root. I want to approximate the cube root of 26. Okay? What is the cube root of 26 close to?
5. No.
Square root of 26 would be close to 5.
3.
3.
2.9.
It's close to 3. 3, if you cube 3, you get 27, yeah. So this is really close. So I'm going to let, again, f of x equal to the cube root of x. So f of 27 equals to the cube root of 27, which is 3. So what point am I dealing with here? Point over 27 and up 3. What I'm doing is I'm using a tangent line to predict a value. And I'm using a set value that I know to come up with it. So, f of 27 is the cube root of 27, which is 3. So now that I've gotten here, what is f prime of x? Y'all do that on your own. Anything, I'm recording this lesson, so we'll go with, that's the only problem we've done other than that. So if you need to go back and watch that whole problem, you can on the YouTube. So what are we getting? As the derivative here.
Oh,
Alright, x to the 1/3. 1/3 times x to the what? Negative what? 2/3, yes. So what's the answer here?
The square root of 27.
1/3 times the cube root of x squared. Are we okay here? And we're concerned about f prime of 27. So f prime of 27 is 1/. All right, now I'm going to do the cube root of 27 and then square it instead of squaring 27 and then taking the cube root of it.
Okay.
So what is the cube root of 27?
3.
And 3 squared is
9.
9. So 3 times 9 is,
27.
so I get 1/127 as my slope here. So the graph is definitely not very steep at this point. All right, well, now again, I can write the equation of my line. My line is y minus 3 equals 1/27 of x minus 27. So this is y minus 3 equals 1/27 x minus 1. So add 3. So y equals 1/27 of x plus 2. Are we still good here? All right. So what is the x value that I'm concerned with here?
26.
26, yeah. This is what I'm trying to approximate. So y is going to equal to 1/27 of 26, then plus 2. So that's 54 plus 26, 80. So I get 80 over 27. And again, you can check that in your calculator. 80 divided by 27 is 2.9 something.
96.
And then you do the cube root of 26 and you should get a number. This should be even closer. And the reason we can feel confident about it being closer is two things. One is, just like in this problem here, your guessed value is only one off from your value that you're wanting to know. The farther away you are from it, like if I'm trying to get the cube root of 24, it's not going to be as accurate because 24 is a little bit further away than 26 is from 27. But also, I know that this is going to be closer because this is not a very steep line right there. 1/27, that's not much change as far as slope from one unit to the next unit. So we can predict this to be really close. So what did y'all get when you plugged in the cube root of 26 to your calculator?
5.099.
Say that again.
5.099.
Cube root. Cube root of 26.
2.9624.
2.96.
So that's for the same,
To how many decimals?
it's the same for the first three.
Through the first three decimals? Okay. So that's to the thousandths it's accurate. So, anyway. All right.